Okay, great. So let's get started. Welcome back to Agriforwards CDT seminar series. I just want to remind everyone that we're still recruiting a new cohort of PhD students in the CDT program, and deadline is end of this month. So I just want please do apply if you are interested in joining our CDT project. So today I have a great pleasure of having Professor Alan Winfield as a guest lecturer today for our seminar series. And he's the professor at the University of the West of England. And he's also probably most well known as one of the founding professors of Bristol Robotics Lab. Is one of the largest lab of the England or UK or probably in the world, working on so many different kind of robotics projects, and probably he knows the most of lots of different areas of robotics. So today he's going to talk about responsible agricultural robotics. And this is actually a very interesting, important topic from CDT, Agriforwards CDT perspectives, because we are responsible in delivering technologies to the society at large. And we need a lot of different things to think about if we need to discuss on this matter. So I'm very happy to have Alan on this lecture, and we will have a time for discussions later. So if you have any questions or comments, please feel free to post your questions in the Q&A window or message in the YouTube channel. So without further ado, I would like to pass the floor to Alan for a very exciting lecture today. So please go ahead sharing your screen.
Yep. So do you see the screen now?
Yes, perfect. Yeah.
Great. Okay. So thank you for that lovely introduction, Fumia, and it's a great pleasure to be with you this afternoon. Delighted. But the first thing I should say, of course, is to make a confession immediately, which is that I know very little indeed about agricultural robotics. But happily, I spent an hour on a Zoom call with Fumia just a couple of weeks ago, just to get myself a little bit up to speed. But it's been a really a great thing for me to have a chance to think about what responsible robotics in agricultural robotics would mean. And so I'm going to share that, those ideas with you in the next half an hour or so. And the talk is in 4 parts. So first of all, I'm going to talk about what we mean by responsible robotics. And of course, that's really a completely generic introduction to the field of responsible robotics. Then I will introduce work primarily by the IEEE on ethically aligned design and emerging ethical standards in robotics and AI. And the third and fourth quarters of the talk will be introducing 2 practical methods for behaving responsibly, for doing responsible robotics. The first is ethical risk assessment, and there I'm going to give you a worked example of what an ethical risk assessment might look like in agricultural robotics. And then finally, I'll introduce briefly robot accident investigation, where I'm afraid I don't have a worked example because that was really too hard, I thought, under the circumstances. But nevertheless, I hope you'll find this interesting. So robot ethics, we define very simply like this. I say we, in fact, this is the definition that appears in my new IET online course on robot ethics. So I define robot ethics as concern with the ethical impact of robots on individuals, society, and the environment, and how any negative impacts can be mitigated. So very straightforward. in practical terms, that really means that you and I, human designers, manufacturers, operators, and maintainers, must behave, as it were, in order to identify and address any negative ethical impacts. Really, it's quite a straightforward definition, I think, of robot ethics, nothing particularly controversial there. Now, responsible robotics really positions robot ethics within the broader scope of responsible innovation. Now, responsible innovation has been around for a long time. It's quite a well understood practice. And responsible innovation is really a set of good practices for ensuring that innovation benefits society and the environment. And this word cloud, which you see to the right of the slide there, really just contains the 6 standard, if you like, or well-known pillars of responsible innovation, particularly these you'll find in, for instance, the 2014 Rome Declaration on Responsible Innovation, and they are open access, governance, ethics, science communication, public engagement, and gender equality. So in other words, if you're practicing responsible innovation, responsible research and innovation, you will be doing all of these things. And a really terrific framework for responsible research and innovation is the EPSRC Area framework. And of course, if you have EPSRC funding, which of course you do, the CDT is EPSRC funded, then you will have had to sign up for this. And AREA is just an acronym: anticipation, reflection, engagement, and action. And I think it's a terrific framework. The most important one of those 4 elements, I think, is the third: engagement. This idea that we should be engaging societal stakeholders in our work, and that's especially work that impacts, on real-world applications such as agricultural robotics. So engagement, I think, is extremely important, and in a way, the others, anticipation, reflection, and action, follow from engagement. So this is my definition of responsible robotics. I say it's my definition. In fact, it's the definition that we've adopted in the RoboTips project, which I'll tell you a little bit about a little later in the talk. So we define responsible robotics as the application of responsible innovation, so the things I've already mentioned, in the design, manufacture, operation, repair, and end-of-life recycling of robots that seeks the most benefit to society and the least harm to the environment. So again, really reflecting on what I've already said about robot ethics. And you can see that this little Venn diagram here positions responsible robotics as a superset of robot ethics, but a subset of responsible innovation. And I think this is important because responsible innovation is not new. There's lots of good practice in responsible innovation. And I think it's important that responsible robotics doesn't have to invent itself from nothing. And there's lots of good practice to benefit from in the broader field, and as I say, well-established field of responsible innovation. So let me now move on to the IEEE initiative, which I've been involved in more or less since the beginning. 2016, the IEEE Standards Association launched this global initiative on the ethics of autonomous and intelligent systems. It's a really terrific initiative, and I would really strongly urge you to get involved if you're not already. The key thing is that the initiative is concerned with the benefit to humanity of change the conversation around robotics and AI from simply wealth creation to the benefit of humanity and the environment. And this is the link, this link here, ethicsinAction.ieee.org. Now, what have we been doing within that initiative? Well, quite a lot. So in 2019, we published the first edition of this document called Ethically Aligned Design. Essentially what it is a set of around 150 concerns and recommendations, if you like, ethical concerns and recommendations, how to respond to those ethical concerns, written by a significant number of people around the world. It really is a group effort. It's an open source document. You can download it. You don't have to pay any money. So please do that if you haven't already seen Ethically Aligned Design. Now, obviously, the IEEE Standards Association is in the business of writing standards, and not surprisingly, EAD and the initiative in general have spun out or is spinning out a number of standards. So P7000, for instance, is a standard in development for the model. It's a process for the addressing ethical concerns during system design. P7001, in fact, is a standard that I lead. I'm chair of the working group and have been since the beginning. A new standard on the transparency of autonomous systems. And there are 14 standards in development right now. So I won't go through these at all, but you can see that there's some interesting stuff going on. Privacy, algorithmic bias, and then a number of standards around data and data governance. A standard, I mean, they range from quite kind of, if you like, soft standards to quite hard technical standards. So P7009, fail-safe design of autonomous and semi-autonomous systems, is a pretty deep technical standard. In fact, the first of these standards to be published is 7010. It's a standard setting out metrics for measuring well-being. I mean, if we're going to build systems that improve human well-being, then we need to measure how well we're doing. And that's an important standard, I think, in that respect. And if you want to find out a little bit more about the emerging landscape of standards, ethical standards in robotics and AI, then I had this paper, short comment paper, a couple of years ago in Nature Electronics. So I'm now going to turn to the first standard that I was involved in. This was published, in fact, in 2016 by the British Standards Institute, and we believe it's the world's first explicitly ethical standard in robotics. And it is a guide to the ethical design and application of robots and robotic systems. And again, I would say, if you haven't seen this standard, then you should request that your library get holds of a copy, or your lab. I think it's really an important standard. Now, what is it? Well, it's basically a method for doing an ethical risk assessment. So ethical risk assessment is very powerful. Of course, it's not new. It's what research ethics committees have been doing for many years. What ethical risk assessment, what the standard does, is that it sets out a method for conducting an ethical risk assessment, really by identifying a set of distinct ethical hazards and risks in robotics and robot systems, alongside measures to mitigate the impact of those risks, and suggestions for how you'd test, how you'd verify that you've actually reduced the levels of risk. And here is, I've just taken a snapshot of some of the ethical hazards just to illustrate deception. So the idea that you might not be aware that you're communicating with a robot, for instance. This is an ethical hazard. So is anthropomorphization. Here's, of course, a very cute robot, Wall-E, my favorite movie robot. It's just an excuse for me to get my favorite movie robot into the slides, of course. And for those of you old enough to remember the Tamagotchi, addiction. So that's just 3 of the ethical hazards, just to give you an idea of the kind of scope of the ethical hazards covered in BS8611. Now, what I'd like to do now, rather nervously, of course, because I'm kind of outside my comfort zone here, but is to offer you a very draft and probably very incomplete ethical risk assessment for an agricultural robot. And I've just picked this weed management robot. But I mean, having written, as I mentioned, for me, several failed applications, grant applications in precision agriculture, I think this is an aspect of agricultural robotics that I've been interested in for some time. So let's look at what the ethical risk assessment might look like. So typically we group the ethical risks under a number of different categories. And this is a group which are societal and human interface hazards. So a lack of engagement with communities would lead to the risk, for instance, of alienation of rural communities. And let's give that a medium level of risk. And the mitigation would be early engagement with farming communities. In other words, early engagement in your design and deployment of your weeding robot. Another hazard, of course, is poor user interfaces. And the risk, of course, is that the farm worker, the farmer or the manager has difficulty navigating and understanding the robot's management systems. So, I mean, I've given this a fairly low risk because with careful design of the robot-human interfaces and very importantly, trials, user trials with the actual people who will have to use the robot, and of course with training, then I think that risk can be mitigated. But of course, if the robot management simply becomes too complex, then you might make things simpler by building a more sophisticated interface that doesn't involve touch screens or menu options, but in fact a chatbot interface. So a chatbot front end to the robot is perhaps a way of addressing an over complex supervision system for the robot. The second set of ethical risks is around resilience, security, and transparency. Poor resilience, really, what I'm thinking of here is that the robot becomes unusable because of either minor faults or inclement weather. I mean, it's of course, if you've run many as many robot competitions, outdoor robot competitions as I have, you'll know that many roboticists tend to forget that their robots have to work in the rain. Of course, I would assume that agricultural roboticists would not forget that. But of course, your design really needs to be designed for fault tolerance and of course for all weather operation. Then weak security. Well, of course, the agricultural robot is likely to be to have a radio connection, a wireless connection, and therefore potentially could be attacked by hackers. And here we need, of course, strong encryption and best practice password protection. But these are fairly standard mitigation practices. They're not particularly unique to an agricultural robot, really. These measures would apply equally to, for instance, a driverless car or a grocery delivery robot. The third hazard on my list here, lack of transparency, really is concerned with the problem that if we don't have a data log, and again, I'll mention this a little bit more in the final section of the talk, we don't have a data log of what the robot is doing, and its decisions, its sensory input, its motor outputs, and so on. in effect, the robot equivalent of a flight data recorder, then it will be impossible to investigate faults or, even more critically, accidents. So the mitigation here is to equip the robot with a secure local event data logger, a black box, if you like. My final set of risks are around environmental hazards. And of course, all roboticists should be concerned with the energy cost of robots, as well as the sustainability of robots. So we should be designing all of our robots, if possible, to run on renewable energy, and of course, to have active energy management to reduce the energy consumption of the machine. We should also be concerned about repairability. And I think this is especially important for agricultural robots. They should be designed for modular repair and ideally for ease of repair by local workshops. I think that's really, really important in this particular field, that you shouldn't have to send your robot off to, to get repaired. Repairability, I think, is really important in many aspects of robotics, and especially for agricultural robotics. Recyclability, again, is important, and all robots, not just agricultural robots, should be designed for ease of recycling or upcycling of parts and of materials. So I'll be very interested in your reaction to this suggested ethical risk assessment when we get to the Q&A. But let me say that the relationship between ethical risk assessment and accident investigation, really they're kind of reciprocal practices, because with ethical risk assessment, you're trying to prevent accidents, you're trying to head them off before they happen. But of course, accidents do happen. They happen all the time, no matter how good your design. Even the best designed robots will be involved in accidents. So you need accident investigation to make sure that we find out, as I show on this slide, what happened, why did the accident happen, and how can the system be improved to prevent accidents happening in future. The primary objective of accident investigation, this is true in aviation, in railways, wherever it's practiced already, is learning. Learning is the absolute #1 priority in accident investigation. And accident investigation requires technologies, it requires process frameworks, and of course also people who can do the investigation, and ideally statutory instruments. I won't talk about those at all. There isn't time in this talk, but I will talk briefly about the technologies. And the key technology is what we call an ethical black box. And I had a paper with Marina Jurotka back in 2017, the case for an ethical black box. We argue, the argument is very simple, which is that all robots, and actually all AIs, or most AIs, should be equipped with the equivalent of a flight data recorder as a standard equipment. Otherwise, it will be impossible to investigate accidents. And not just accidents, but near misses. And of course, in aviation shows us that the investigation of near misses is just as important for improving safety as the investigation of actual accidents. So really the data, providing the data that allows you to investigate the accident, if you like, the ground truth, is absolutely fundamental. So this is something that we're advocating for very strongly. And again, I don't have time to go through in detail, but in a new paper that's going to be published just in a week or two, called Robot Accident Investigation, a case study in responsible robotics, we have a worked example of an elderly person with an assisted living robot. And we follow, if you like, a fictional accident and how exactly that might be investigated. And part of the accident investigation is the data from the ethical black box. And this picture just shows you a kind of a visualization, if you like, it's an annotated timeline from the ethical black box showing the Rose's fall. This is where she fell and a neighbor discovered Rose on the floor unconscious. The robot was wandering around. They're not sure, the accident investigation team is not sure whether the robot caused the accident. Maybe it didn't cause the accident, but clearly it made matters worse. Apart from anything else in this particular example, the robot fails to raise the alarm. So that is clearly a major concern of the accident investigation team. And in the paper, we propose a well-known technique called why-because analysis to allow you to construct a why-because graph in order to link the events, which are a combination of events, a change of state in the world, processes, things that are happening that are pertinent to the accident, states of the world that are relevant, and also unevents. Unevents are important because they're events that should have happened but do not. And this, in fact, this graph shows us how those events, processes, states, and unevents lead to actually two accidents. Accident one is Rose's fall, and accident two is the robot failing to raise the alarm. So I'd like to invite you to look at that paper. In fact, there's a preprint already on Archive to look at the process that we're proposing for robot accident investigation. And that brings me to the end of the talk, but I just wanted to mention that the work that I've just described on ethical risk assessment, on responsible robotics, and on robot accident investigation all forms part of this project called RoboTips. It's a 5-year EPSRC project led by my colleague Marina Jarotka at Oxford. And this is the webpage, robotips.co.uk. And perhaps I'll mention just one thing about the project, which you might find interesting, which is that we're conducting a series of mock robot accidents with real robots and real humans, but with human volunteers as both the subjects of the accident, human witnesses to the accident, and also human members of the accident investigation team. And we're going to be running that for 3 different robot scenarios, which are likely to be assisted living, robot toys, and autonomous vehicles, all of which we happily can do in our lab here in Bristol. So at that point, I'll stop and hand over back to Fumia.
Thank you very much, Alan. This was an excellent lecture, and I actually have your book with me here.
All right.
It's a very good introduction, very short introduction, but very nice. Thank you very much. This is a highly interesting topic, and I'm pretty sure lots of people have lots of questions. So please feel free, post your questions in Q&A window. Let me start with my questions. So as you know, we have more and more autonomous robots and more learning robots, right? Machine learning is becoming more popular. And we tend to be attracted by the idea of black box approach of designing robots or controlling robots. What's your views on this? Like, obviously we have more black box, the more difficult to investigate, and the probably is more difficult to follow, or the ethical standards you are proposing. Do you have any views or suggestions or ideas how we should deal with such a direction of, I don't think we can stop this direction of research anymore, right? How do you think about this kind of problem?
Well, that's a great question for me. Now, the first thing I should say is I'm an old-fashioned safety critical systems engineer. So I spent the first 10 years of my professional career running a business developing safety critical systems. So I take a very hard line on safety critical systems. And to put it simply, for me, I believe it's deeply irresponsible to use any machine learning at all in safety critical systems. That, of course, puts me immediately at odds with, current developments in autonomous vehicle autopilots. And it's interesting that the well-known and well-publicized accidents that have already been investigated by the NTSB in the US, the National Transport Safety Board, have demonstrated that the NTSB, the accident investigators, have not been able to discover precisely, as it were, the root cause of the errors, the decisions that were made that prompted the accident. So there's a degree of opacity in the the machine learning systems in the autopilot that make actually getting to the bottom of the accident impossible. Now, I think in less than highly safety critical applications, I think it's probably okay. I mean, my preferred approach is not to have a pure machine learning approach, but to have a hybrid approach where you have a kind of watchdog, if you like, or supervisory control system that monitors the decisions that are being made by the machine learning system. But if you have to have a machine learning system, then I think our ethical black box, our data recorder, in other words, should as a minimum should be logging the weights of the neural network periodically, certainly after any learning takes place. Of course, typically the ones that are used at the moment aren't doing online learning, or that's my understanding at least, because it's quite hard to discover from the manufacturers exactly what they are doing. But at least if you capture the weights, then you can reconstruct the machine learning system as it was at the time of the accident, in order to be able to reproduce, at least even if you can't understand exactly why the network gives that particular output for those particular inputs, at least you can reproduce it, which would, I think, be a help. And then you can combine that with other techniques like counterfactual analysis and techniques that are used, for instance, in looking at why machine learning systems have given the wrong output for facial recognition. So I think there are, but it always worries me, because really the machine learning community are having to work incredibly hard to provide traceability, when in fact good old-fashioned AI, the thing that you and I and most of us probably on this call learned and were raised with, it's easy to provide traceability with good old-fashioned algorithmic AI. And I think, that's why we should certainly not be throwing away good old-fashioned AI anytime soon.
Yeah, thank you, Alan. So Richard, do you want to go ahead with your question?
Yeah, I have a boring question and an interesting one. So let me choose the interesting one. I heard a talk from Peter Cochrane, the futurologist, and he was asked, how do you decide when you should switch to autonomous driving vehicles? The example that you just talked about, Alan. And he said, well, when they kill fewer people than humans is the switch. Now, that seemed pretty reasonable, but it's not what you've just said at all. Not at all. You're demanding, maybe rightly, very high standards from robotics, much higher than humans. So so my question is, how much higher is the right higher? Do you see what I mean? There's a continuum, and right down here I've got what humans do, which I regard with some asperity, is low, and right up here is what you seem to be demanding. And there's there's some variance in my mind about where you should demand of robots.
It's a really interesting question. And in fact, I'm part of a current project, ESRC funded project, led by Jack Stilgo at UCL on driverless. It's essentially called driverless futures. So we're looking at the policy implications of driverless futures. And that's one of the questions we're looking at. And of course, the simple fact is that we expect our machines to be much more reliable typically than a human doing the same thing. And I think that's a very reasonable expectation. So, so I think the idea that we would be happy with driverless cars that are only just as good as humans, as the average human driver, is not right. We would simply not.
Can I sort of press you, because the point at which they're killing less people, it becomes a bit unethical to continue with human drivers, doesn't it? Because you've got something that's less dangerous, but you're refusing.
But what I'm saying, I'm agreeing with you, but the point is it has to be much less people, not just less people.
Any idea as to where?
No, no, because essentially it's society that, you know, it's we collectively would have to agree on what is an acceptable margin, if you like, of improvement. And of course, people like, you know, Elon Musk do typically complain, you know, you know, that we're setting the standards too high, but actually that's right. I mean, we, you know, in a way we set the standard, we do already. We, you know, the way that we design and build aircraft autopilots is exceptionally tough, you know, for designers of aircraft autopilots. And some people have often said, yeah, but hang on, we don't expect human pilots to be as good. Well, that's true. And that's simply a fact of the way we do engineering. We typically expect our machines to be much less fallible than we humans.
Okay, yeah, good answer. I mean, I wondered if vaccinologists might have something to say, you know, because they're having to weigh these things all the time.
I've often debated with people about whether, you know, there is a suggestion in the wind that you should treat AIs like vaccines and do statistical, you know, accept statistical measures. But of course, aren't we really doing that? You know, the people who say, well, when we have fewer than X deaths per mile driven, then that's, you know, that's when we switch to. That's also a statistical argument.
Yes.
Yeah, but I mean, but the problem with, of course, vaccines is that a lot of them, even the common ones, like, you know, they don't have to be vaccines, just paracetamol. We don't actually understand how it works at all, but we still accept it because it's, you know, it does work, you know, most of the time.
Okay, thanks. Yeah.
You're welcome. Good question. Yeah.
Okay, we have some other questions in chat window. Shaun, do you want to come out and speak your question?
Yeah, sure. So you talked about the importance of repairability, and I mean, I agree with you. It's a huge issue in agriculture. The current ag machinery makers, so the people that make like big tractors and big combines and things like that, they fight repairability. They have fought repairability at every step. And continue to do so.
Doesn't surprise me.
How do we stop agri-robotics just going down the same path of the current track? That, you know, like we kind of have a chance to change things potentially with the new technology through. How do we stop ourselves just repeating those same mistakes?
Well, it's a good question. I think you know, it's about monopoly. And of course, I've noticed in the press recently that one of the big tractor companies, I think it's John Deere, has just acquired one of the agricultural robot startups. And what we desperately need is for that not to happen. Because, you know, the reason, of course, that, you know, in big AI, the reason that Google and Facebook have effective monopolies is that they've essentially hoovered up all of the small companies with potentially competing or, you know, competing technologies. And I think what we need to assure repairability is an ecosystem with a large number of small and medium-sized companies rather than just one or two, you know, big equipment manufacturers and nobody else. Now that's a political problem. And of course, a lot of ethics in robotics and AI actually boil down to political decisions. It's really only governments who can prevent that.
Is it harder to avoid monopolies with something like robotics, where it's relatively technical? You need, you know, the initial capital cost to develop a new machine that is like effective is quite high.
Yeah.
Which is like, there's barriers to entry, which means like it's harder for small players to come in and do it. So does that offer some additional, does it make it more likely that you'll just end up with monopolies?
Well, yeah, I mean, I used to think that, but of course, Google went through a phase of buying up robotics companies. And then I think they decided against it and they divested themselves. But I think they were hedging their bets somehow there. But I'd like to agree with you, but I fear I don't, because I think, you know, monopolies like to hoover up, you know, so, you know, but I think what we need is pushback from the community. So you know, as I often say to my colleagues, you know, robotics needs to get political, and that means, you know, that the user communities need to get political and push back against this kind of trend, and really try and support as much as we can the startups and the small and medium-sized companies, and get very cross when they sell out, you know, to Facebook, or, you know, I'm thinking of the what are they called? I've even forgotten the name. The VR manufacturer, VR headsets.
Oh, yeah.
Yeah,
Well,
who raised all their funding on Kickstarter and then sold out to Facebook.
Oculus Rift.
There are tractor hacker groups that hack John Deere tractors to make them repairable.
Yeah, well, good. I mean, I support that kind of guerrilla movement, yes. And but I mean, you know, particularly, I mean, I understand enough about precision agriculture that to understand that it especially will benefit smaller farmers, smaller landholders, because it allows you to make, you know, a land which is not viable, you know, using big machinery, suddenly becomes viable. Hillsides and rocky, you know, fields. And, you know, I was thinking of one of these failed EU bids had you know, Italian vineyards as a potential user. And I think one of the great attractions of agricultural robotics is that it should become available, make this technology available to small local farmers, not, you know, not only the sort of huge mega farmers. And again, that, you know, that really would benefit from a rich, vibrant ecosystem of smaller manufacturers and suppliers who can work in and with those communities and support them in the way that they should be supported.
Thank you.
Okay, thank you very much. Minia, do you want to ask your question yourself?
Yeah, hi, thanks for the lecture. Yeah, so I was wondering, since you mentioned that robot ethics is kind of a subset of responsible robotics, what other things would you consider to be part of responsible robotics?
Oh, sure. Well, gender and ethnic diversity is super important, and you know, I think it's, you know, we have this extraordinary situation right now where most of our AI, and I'm referring to AI rather than robotics, you know, is developed by exclusively, you know, young white men. Well, it's not surprising that AI is not a good fit to, you know, to society, because society is not, you know, exclusively, you know, populated by young white men. And I think it's critically important that we have robotics companies that are, you know, diverse. That's part of being responsible. And I mean, we have some really great examples, startups from my lab, which are really outstanding examples of the kind of responsible approach that I'm advocating. One of them I'll mention is Open Bionics, a company that does remarkable low-cost 3D printed prosthetics for children and young people. That is hand and arm prosthetics. And they are a remarkable example of the right way of doing responsible robotics. You know, there are other aspects. Ethical governance is another part of it. And Marina Jarokra and I, again, have written quite a I think now well-cited paper on ethical governance. So all the things that a company should do in order to make sure that its entire operation is ethical. And of course, that's far more than just ethical risk assessment and providing the processes and mechanisms, if you like, for accident investigation. Those are just two, if you like, practical aspects of ethical governance. So I hope that begins to answer your question. But do check out the literature on responsible innovation. In fact, there's a really great EPSRC project called Orbit, which I think stands for the Observatory for Responsible Innovation in IT. And they have a website with a terrific set of resources on responsible innovation.
Thank you. Yeah, so that does answer. So it's also kind of considering the ethics of the surrounding systems of the robotic or AI solution, not
Exactly.
only the ethics of the robot itself.
Precisely, that's
Thank
right.
you.
It's the entire, superstructure, if you like, of the way it's designed, built, managed, maintained, operated, and so on. Yes, that's right.
Thanks. As just an aside, I actually have worked with Open Bionics hands. Really cool.
Oh.
For a robot that was teaching sign language for children with autism. So
oh, wonderful!
Yeah, great
so
work on that.
You know them. They're amazing guys.
Yeah.
Really terrific. Yeah.
Yeah. Thank you.
Great. Thank you.
Okay, if you have any other questions, feel free to raise your hand and you can ask your question. So let me ask another question from my end. So I think majority of audience today is technology students, working on actual robots or some technology aspects of it. And yourself, myself, we're all engineers, so we kind of understand how difficult it is to actually make things work before thinking about any of this ethical, responsible matters. I'm kind of wondering, what would you suggest to all the students and engineers, or especially young engineers who are really busy making things working? What kind of advice you give, in what way we should think about this responsibility, and or is it something someone else can think about it, or is this we all should have think about it, or what do you suggest to this community in general?
Yeah, no, it's a great question. Well, I would say, if you're a young engineer and you're working in the lab, you're trying to design and build a new algorithm or a new kind of robot. It's okay, of course, to get lost in the engineering. It's wonderful. I mean, I do it myself. It's a joy to do the engineering, but I think it's important that every single person involved in a real world application. So, I'm not saying that we don't have ethics in a research lab. Of course we do, we have to. And if you have EPSRC funding, we do have to, innovate responsibly. So it's not an option. It's not something we can opt out of. But especially for real world applications, and of course, remember, and of course, all as well as I do, that there isn't actually a very big distance between robotics in the lab and robotics in the real world. I mean, yes, we have to solve real world problems, but actually, it didn't take very long, for instance, for the ideas in the lab in terms of 3D printed prosthetics to get to real products with, being used by real people. So I think everyone needs to have ethics in the back of their mind, even though, the ethical practices may not be important in that moment while they're working on the bench or whatever, or in a field trial or something like that. It's important to keep them in mind, because if you don't, they will come back and bite you. The way to think about ethics, I think, is this: that doesn't matter how good your design is, or you think your design is, you can never design ethics in at the end. And it's the same as quality. So, I mean, I'm old enough to remember, manufacturing industry in the 1970s and the 1980s, when manufacturing, particularly car manufacturing in the West, in the UK and in Europe and in the US, had serious competition from Japan. Japan was much better at quality than we were. And the manufacturers in the West that failed to compete went out of business. And what they learned very quickly is that you cannot inspect quality in at the end. You can't hire a quality manager or a quality department and believe that you've done quality. Tick, we've done quality. We've hired someone to worry about quality. No, the companies that succeed in quality or succeeded at quality management, several decades ago, discovered that everybody in the company has to care about quality. Everybody, without exception. From the person who works in the post room to the CEO, and especially the CEO. So ethics are the new quality. Ethics is something that everybody in the organization needs to know about and understand and care about. Otherwise the end result will fail. So I think that my simple message is ethics are the new quality. Doesn't mean you shouldn't become obsessed by them, but I think everybody without exception should have some training in ethics. Take a course, take a module or two on robot ethics or whatever it is, AI ethics, and then have it in the back of their mind.
Is this the kind of thing we should include in the education courses? And if so, what's the best way of doing it? Because, to be honest, this is the first time I actually learned anything formally about ethics today.
Right.
From you.
Right.
And most of the academics in teaching positions don't have this background, right? So it's kind of very slow process, propagating across this academic world of robotics in particular. Do you have any kind of idea how we can make moves in a positive direction from here?
Sure. Yeah, well, absolutely. I mean, certainly for some years now, we've been offering ethics in technology modules and workshops for our CDT students. So I've been helping to deliver those parts of those courses. I've also in the last couple of years helped at universities of York, Sheffield, and Cranfield, again to give guest lectures, as part of whatever. I'm not sure what the master's programs or graduate studies programs typically for both masters and PhD students. So what I would recommend you do for me is to try and build in. You probably can do quite a lot in, say, 2 hours of teaching with perhaps another 2 hours of workshop added onto that. And I mentioned earlier that I have this IET online course, which you might be interested in adopting. It's I don't have any I don't have any commercial benefit. I don't own it, so I'm not I don't gain anything by advertising it. But of course, I mean, I put into that pretty much all of the kind of thinking and whatever I've learned in the past 15 years or so. I've built into that course, and in fact, I'm now. I should say that I retained the copyright on the narrative part of the course, and I'm going to use that for a new book. So I'm working on a new book on, if you like, the practice of robot ethics. There's plenty of theory on robot ethics, but I think what we need is practice.
Yeah, thank you very much, Alan. I think this was a really great concluding remark, and we're looking forward to publications coming out, and we can learn from those. Once again, thank you very much, Alan. This was a really excellent lecture on robot ethics and responsibilities as an engineers, and we should certainly follow up on all these topics in the future of this project.